Hello everyone. This is just a quick video to just kind of quickly go over the connection and initial setup of the Accublast coolant nozzle. So this layout here represents a Pro kit, and that means you'll have this, which we're currently calling the inputs box, a display, and then of course the nozzle unit. So the first thing you need to do is connect power to the unit. So on the inputs box, the outermost pins on this side are 24 volts and ground. So it says here 12 volts 2 amps, 24 volts 1.5 amps. So you need to supply this with between 12 and 24 volts DC on these two pins. That's the only power connections that the system would require. So once you have that connected, then you can connect the servo unit wiring, which is done on this connection here. If you only have one servo unit, you're going to connect on the S1 side. So these, the three pins on this side, S1, ground, and 24 volts. So on the cable that you get, that's going to be blue, black, and brown. So just be careful that you match the correct colors to the correct screw terminal pins. Then you're going to connect the display, and it depends what hardware level you have. The most current ones, as of this date, will actually use an RJ12 cable. So that's a 12-pin, like a telephone cord, you'd kind of recognize it as. This one here is the previous hardware revision, so it has a Cat5e cable, so there are RJ45 jacks. So all that matters is just you may be using an Ethernet cable, or you may be using a telephone style cable, but you just connect it between the inputs box and the display. So one word of caution: never plug these cables into a network or into a phone jack or anything like that, because there's 24 volts present in these cables, so you will destroy whatever you plug them into. So I'm going to go ahead and plug the wall wart power supply in. Basically, you can just use one of these types of class 2 wall wart supplies. So this here is a 24 volt one. I've got a link on the website for a power supply like this. So I'm just going to plug this into the wall. And then the device is going to start up. Now, this is basically what you'll see when the system starts. So the green box represents what signal or what setting that you're currently adjusting. So right now it's on nozzle angle. So if we rotate the knob, you'll see that the coolant nozzle will change position. If you click down on the knob, that's how you advance through. So you can scroll through all the different options. You can press back at any time to get you back to the nozzle angle adjustment. So this is where you set the current tool number. So if you're using this just as basically a manual coolant nozzle, so you're not integrating into the machine to know what tool is currently loaded, you can manually scroll through the tools, and you'll see that it will recall the last nozzle position that you had set. So if we advance one more, this is twitch. So twitch will start a oscillating motion on the nozzle. So there's 1, 2, and 3. So you can see that the larger the number, the further the sweep angle is. So these twitch settings are also stored. So if we go back to tool 2, it was at twitch 0, so it's obviously not twitching. And if we go back to tool 1, it recalls that we had it set to twitch 3. So again, it recalls all of that for you. Sync, you can turn it on if you have two nozzle units, which you can connect to a Pro kit. It will basically slave the second nozzle. So if we go to number of nozzles 2, you get the second nozzle control up here. So basically, if we turn sync on and we just adjust nozzle 1, you can see that nozzle 2 follows suit. Now the cool thing is that you can set the offset between the two of them. So if we go here, we don't want 83 degrees between the two of them. Maybe we want less. You could bring this all the way up to 83. This isn't how you would have initially started this, but you can basically set the offset between them, and then it will keep tracking the same offset as you adjust N1. So it just makes it easier to control both of your nozzles. So we'll go ahead and turn sync off. We'll turn number of nozzles to 1. The next is auto. So X7A, that is carousel detection. So that's on the SILE X7. And basically you connect the clockwise, counterclockwise, and index pins from the automatic tool changer into here, and it will follow the machine along to know what tool is currently loaded. Then we have pulse. Pulse, there's a pulse pin, and basically when you're on pulse, it's waiting for pulses on this pulse pin. So this wire I've got here is connected to pulse, and I'm going to come over and just tap it on the 24 volt pin to simulate it receiving a 24 volt pulse. I'll just tap it a couple times. It's not going to just go to 2, but basically it will demonstrate how this system works. And sorry, I was using the aux2 wire. That's for something different. So there, so it thinks I did it 12 times just because of course it's monitoring for some very fast pulses. Now if we just try my best to do 1 pulse, we can see, it went to 4. So anyway, that's how it works. It'll count the number of high pulses it receives within about 1.5 seconds and then take that to be the tool number. That's just kind of a quick overview of how that works. The next thing is there's NGC. So this is for Haas. Currently, this is the only Ethernet option I have. So if you bought an Ethernet equipped inputs board, then you're going to connect it to the network, and I'm going to do a separate video on how to do that. And again, this is machine data collection. So again, for Haas machines, this allows you to pull the tool information from the machine data collection on the mill. Again, I'll cover that in a different video. So we're just going to turn that off. In2 mode, so there's this aux2 input. So that's the one I was accidentally tapping on before with this yellow wire. So there's only one option for this right now, and it's TWP, and that means twitch hold, so twitch pause. So if we tried to turn, if we have that set to TWP and we try to turn twitch on, it's going to give us a warning that the twitch function is holding. And what it's holding for is a signal from the coolant pump, because there's no sense having this oscillating and wearing and creating heat when the coolant pump isn't running. So you wire aux2 to a 5 to 24 volt DC high signal that coincides with when the pump is on. So I'm going to simulate that now by taking this aux2 wire and putting it on the 24 volt pin, and you can see that the twitch function is restored, and you can see that the warning flag goes away. So that's how that works. So we'll turn that off. And aux3, there's no function for that yet. This will set the direction of rotation. So if we go back, I'm going to rotate this clockwise, and you can see which way the nozzle moves. If I go change N1 direction to reverse, and we go back, and I'll turn the knob the same way, clockwise, you can see that it's going to go opposite. This is so that no matter what way you have the nozzle installed in your mill, you can set it so the knob rotates with the way you'd expect the stream to adjust in your mind. So it just gives you a bit more control in case you have it mounted with in a way that you might consider backwards. Version Pro, this represents a Pro kit. If you go to Basic, it expects this is not there, and you have some direct connections made right to the display. So it's a simpler system, but it doesn't give you some of the extra functionality of the Pro kit. Number of tools. So if you can set this to basically however many tools you want the system to remember. The system will remember up to 60, I believe, tools. Or no, sorry, it's actually up to 200. It'll remember settings for 200 tools. Now, this is very important if you're using the carousel connections like for a sile or very soon on a fatal, or a fatal, I'm not sure. Basically, because when it's using just these carousel motor connections, it doesn't know how many tools are in the carousel. So this is where you need to set that so that it knows as it passes by. If you have it set to 12 and you go one past 12, it knows to go back to tool 1, if that makes any sense. So anyway, it's very important on some of the automatic modes to make sure this is set correctly. And then again, we went over a number of nozzles. So that's basically the general overview of the system. You know, you're obviously going to have a 3/8 NPT fitting here, and to connect to whatever kind of coolant piping you're using. So this is a 1/2" OD push to connect fitting. So there's a 3/8 ID. So through the nozzle unit itself, it's 3/8 ID. So if you want to match that, that would be the kind of size of pipe or hose you'd want to use. Yeah, that's basically all I wanted to cover in this video, was some of the basic connections and operation of the system. And this unit here, you can see the blue is a bit off, and it's a different color than the turret. That's because this guy actually is out of my mill, and it is the very first one that I ever made out of the version that I started to sell. So this one has been in my mill ever since. So it's kind of the old color and some of the old hardware features, which, you know, if you weren't looking for them, you probably wouldn't notice the difference between the newest version. But this one's still been plugging away in my machine. I haven't actually had to change anything in it. So it's been relatively reliable, and that's kind of why I want to keep using this one in my mill, is just to get a basic idea of how reliable these systems might be. So there you go. That's the end of this setup video. Next, I will be doing one on the Ethernet connection for the Haas machines. So thank you very much, and I hope this was useful to you.